Take 400. Let's talk about water chemistry. So this video has been a long one to kind of make because I've filmed several different iterations where I'm talking ad nauseum about a bunch of stuff and just getting derailed and off track. But I figured out a way to make this a little bit more concise. So what I'm going to do is overview my approach to water chemistry in a small brewery. So hopefully this helps you on whatever scale you're brewing at. First things first, what is water chemistry? You hear that term a lot in the homebrew world, and my simple definition is identifying and adjusting minerals in the water that you're using for the brewing process. So there's a few different sources of water that you can use for brewing. The most common is direct from the tap, so city water, whatever comes from your municipality's water treatment plant. You can use distilled or reverse osmosis water. This basically is just pure H2O. It strips all the minerals out of it, so you're just working with a base, and then you build up from there. And then you can also use, like bottled water, spring water, things like that. I don't recommend that. That gets a little costly. If you have a well, then you're going to deal with a whole host of other issues with mineral content. So we're going to focus specifically on using your city's water for brewing it home or wherever you brew it in a brewery. The first step in water chemistry is finding out what the mineral profile is of the water that you're using. Most municipalities will upload water quality reports on their website. So you can go and Google your city's website and they should have water quality reports. During the filming of this video, I looked up the Temple water quality report and found that there's not a recent one since 2021. So that's a little bit of a bummer, but I'm going to go ahead and use that for demonstration purposes, and we'll talk about that later on in the video. The other thing that you can do is get a sample of your water and send it off to get it tested at a lab. There are plenty of places that do it. I'll throw up a name of a place that does it right here on the video. But you can get that water quality report and then see what the mineral breakdown is of your tap water at home. And then you can start approaching water chemistry for brewing. The reason that we even focus on water chemistry in the brewery is kind of twofold. In my approach, and this is what we're going to be covering today, the first step is adjusting the water profile during the mash so that you can hit your pH range that you want to hit. I shoot for a 5.2 to 5.3 pH range for each of my brews. And what I do for a pale beer, which is a much more basic solution, a basic mash, we need to acidify that. So I end up adding salts into the mash to acidify that pH so that it hits that range. If we're brewing a darker beer that has a lot of roasted malts in it, it's going to be much more acidic in the mash. So we're going to put in something that's a base and bring that pH down. So in that case, I would use like baking soda or something. But for this video today, we're going to focus on a pale lager, and I'm going to cover all of the aspects of how I approach water chemistry in the brewery. Okay, so the first step, like I mentioned, is to find your city's water report. I have here a water report from 2021. Like I mentioned, it's a little bit older, but this will give a good baseline for the process here. So we have a list of all of the constituents in the water, different minerals broken down by parts per million. And so we're going to use this information and import it into our brewing software. For this particular recipe, I'm going to use the 10-degree pale lager. I did a video on how I built this recipe for I did a video on how to build the recipe within Beer Tools Pro for a 5-gallon homebrew batch. So we're going to use this as a baseline. First, I'm going to go to the recipe drop-down menu and click water chemistry. And then I'm going to click browse water profiles. This is going to bring up a list of all the water profiles. So what I'll do is I'll take this water profile sheet and I will take the values for each of the minerals, including the bicarbonate alkalinity, and I'll import it. I will type it in physically into this water profile so that it's an accurate representation of the water that we're using. But basically what I do is I'll click new water profile. I'll name it Temple, Texas. And then I'm going to go ahead and update all of these numbers to reflect the numbers that are in the water profile. So I've updated my water profile here. Calcium's at 55 ppm, magnesium 11 ppm, hardness as CaCO3 is calculated based on these other minerals. Na+ is sodium, Cl is chloride, HCO3 is bicarbonate, and that's a measurement of hardness and alkalinity. And so I entered that here, and the sulfate is 24 ppm. So now that I have this water profile saved, I'm going to click OK, and I'm going to add it to my recipe. So here's the water chemistry box here and the Temple, Texas water profile. So the first step in the process, like I mentioned, there are two parts of water chemistry as far as how I approach it. There is the flavor constituent, so the minerals that kind of accentuate malt flavor and hop flavor and promote yeast health and flocculation and things like that. That's for the overall flavor of the beer. But the first step in the process is making sure that we hit our mash pH. And I personally was trained to use minerals that we're going to add to the beer anyways as the pH adjustment. So that's the step that we're going to do right now. The first step is to enter the strike volume. And in this 5-gallon batch scenario, we're going to use 2.1 gallons of water. So I update this at 2.1 gallons of water. And then I'm going to go to browse mineral salts. And I'm going to bring in calcium chloride and gypsum. Those are the two most commonly salts that I use, unless I'm brewing a dark beer where I need to have a base. And in that case, I use baking soda in the mash to buffer that pH. So now I've got calcium chloride and gypsum in the water chemistry profile. So now you may be wondering, how do you figure out how much you use to adjust the pH? Well, we're going to go ahead and pull up this is a picture I took of the chart in the water book. So there's a brewing series of books, water, malt, yeast, and hops. They're very helpful tools and resources when you're home brewing and even professionally when you're brewing. The yeast book is awesome, by the way. But in the water book, there's there's two charts. There's one for ale styles and lager styles. We're going to reference the lager style today because that's what we're brewing here is a lager, but you can use this concept for any of the styles. So on that diagram, it's going to show several different categories of beers. It's going to, on the left-hand side, it's going to identify the strength of the beer. And on the right-hand side, it's going to give you examples of different styles that would fit within that particular category. So we're brewing a light lager. It's pale in color, and the bitterness is going to be soft. And so it's at the very top of the chart. And if you look to the right under styles, it says light American lager, standard American lager, Munich Helles, and Bohemian Pils. So that's going to be the perfect category for what we're trying to brew today. The way that we adjust the acidity in the mash with these salts is by referencing this number down here. This is the residual alkalinity. You can dive deeper into this by picking up a copy of this book and reading more about it, but we're just going to do broad strokes here today. The lower the number, the more that you need to, the more acidification is happening, and the higher the number, the more basic profile it is in the mash. So this number needs to be between -60 and 0. So we're going to toggle these salts up and down until we get right within that range. So let's go ahead and put 3 grams of calcium chloride and see what happens. It dropped that to 7.94 residual alkalinity. So we need to go a little bit further. We'll do 3 more grams of gypsum, and that takes it to -33.84. So that is right in the middle. And just based on historical brewing knowledge, I know that will most likely end up in a pretty good spot for this beer. So now we can move on to the next step. I always shoot to the middle of the range just as kind of taking the first stab at a new recipe. And then once you brew the beer, you'll have data and you can come back and say, hey, my mash pH was a little bit higher than I wanted. So maybe we add a little bit more salts to acidify it slightly more, or hey, my mash pH came in a little bit lower than I wanted. So we can reduce those salts as needed. So this looks good. The next step is increasing the total volume to what our knockout volume is going to be for the beer. This is important because beer is mostly water. So we're going to assume that all of the minerals carry through the mash and into the boil kettle. And when we increase the volume to the final knockout volume, this is going to give us a good representation of how much minerals are in the total volume. So we're going to make this 5.2 gallons because that is the final volume of our beer. And then we can start looking at the actual mineral content. So there's a few reasons why this is important. Sulfate and chloride are the two main salts that we look at when we're talking about water chemistry. Chloride tends to promote more that malt character, that roundness, that sweetness and body in a beer. And then the sulfates will accentuate kind of the hop bitterness and the hop character. If you were brewing an IPA, you would potentially have like a 3-to-1 or 4-to-1 sulfate to chloride ratio. But in this case, we will have them about a 1-to-1. And I've even, depending on the water source, if we decided that we wanted more chloride, in fact, I do want more chloride in this than I want sulfate, you can kind of retroactively adjust these two salt additions that we did in the mash. And for this scenario, let's go ahead and bring that gypsum down to 1 gram and the calcium chloride up to 5 grams. So they acidify to the same degree. So it's pretty much 1-to-1. And you can go back and check on this. So like if you wanted to, so this reduced our sulfate and increased our chloride. If I wanted to go and double check to make sure that the salts were still adequate acidification for the mash, I could go ahead and reduce this back to 2.1, and it would show me that, in fact, it's actually a little bit lower. So let's reduce that. And this is real time. So this is, you're seeing me work through the process. This is how I approach it whenever I'm developing a new recipe. So we can bring that down to 4. Okay. Yeah, a little bit lower, but I would probably, let's just keep it at 5, just for the sake of this. So 5 grams of calcium chloride and 1 gram of calcium sulfate. So we can now increase this back to 5.2 gallons, and we can approach the rest of the minerals now. So according to our chart, we are looking to hit calcium. We need it to be at right around 50. So this is much higher. And I haven't seen any mal-effects from this on my system. So this is the water report for the city water that I use. And I have not seen any mal-effects from this number being too high. Calcium promotes yeast flocculation, and it's just overall, it's good to have it in the beer. But that number is a little bit higher than I'd like it. So you could, theoretically, if I were to take a step back and say the perfect way to approach brewing this beer on the system that I have with the water source that I have, maybe I don't acidify with salts. Maybe I just, if I were to take all of the salts out, that would be perfectly in line with where the beer needs to be. And then I could acidify with lactic acid or phosphoric acid, but I'm just being transparent. This is how I acidify. So we'll leave that in there for this example. Now we can move on to the sulfate. So the sulfate needs to be between 0 and 50 according to this chart, and that is right around the 50-degree mark or 50 ppm mark. So that's solid, and the chloride should be from 50 to 100, but it's a little bit higher. Again, you could go back here and toggle this down to 4 grams, and that's not really making a huge difference. So it's really up to your discretion. So that's a little bit higher, but again, chloride kind of enhances the overall malt character and body of the beer. So a little bit higher on this particular category, I think it's totally okay. And I love the results that I get with this particular mineral profile. So I'm cool with that. So now that we've got the salts figured out and the total volume of water's in there, this is pretty much good to go. You can adjust these accordingly, again, for the style of beer that you're trying to produce. I personally like to use this chart as a guideline, and then I will adjust and kind of see how things work out. If I make a little tweak here and there, one good rule of thumb, anytime you're trialing something, is change one variable at a time. So maybe you had a little bit more chloride in this batch and you wanted to decrease that, just try to decrease the chloride. It's difficult since these are paired calcium chloride and calcium sulfate. But just as an example, try to isolate one variable at a time. Anytime you change something in a recipe, it takes longer. You have to brew more batches of beer, but this allows you to see what is actually changing. When you're adjusting these variables in the beer. So that is my approach to water chemistry and how I build it on a recipe. And I hope this was helpful. I spent many different spent many hours today filming this and writing things down and trying to make it as concise as possible. And I was just kind of all over the place. But also we had a tree trimmed and fell and shattered this window right behind me. So I'll show you a picture of that right now. And so that kind of was a disruption. So yeah, that's pretty much all I got here. Let's do a wrap up. All right, I forgot to mention before ending the recording of this video that if you needed to bring up any of those specific minerals in a category for the beer style that you're brewing, for instance, if you needed to increase the sulfate in the, if you were brewing an IPA or something, you will calculate it on that water chemistry tab, and then you'll add that addition of salts into the boil at about 15 minutes before the boil is done. So that's usually when I add Whirlfloc, yeast nutrient, and additional salts if it's needed for the specific recipe. All right, wrap up time. So we talked about what water chemistry is and why it's important to the brewing process. We talked about different types of water sources. We went into a recipe and I showed you how to open the water chemistry chart and adjust it on the Beer Tools program. We talked about how to acquire a water profile report. Yeah, the importance of why we are concerned about water chemistry at all in the brewing process. So I hope this was helpful to y'all. I've had a lot of requests about doing this video, and by a lot, I mean probably like 3 or 4, but I am happy to finally get this stuff out of my brain. If any of this was confusing, please let me know. I'm happy to dive deeper into this, but for the sake of a YouTube video, I thought that this was an adequate approach to it. So this is by no means the best way to do water chemistry. Again, I brew on a very simple system. I am not attempting to recreate the Pilsen water profile. I think that the water that I use in Temple is adequate for brewing the beers that I'm brewing. And honestly, I've gotten great results with using city water. So do what works. That's my advice in pretty much everything in life. And I think that it applies here to brewing as well. So feel free to go off and use this recipe. Try to adjust the water on your own and get some water reports from your city and see how it differs from maybe my water report. Let me know what your water report's like. Do you have hard water? Is there a bunch of sulfate in your water? Is it pretty soft? Let me know down in the comments below. Like and subscribe, share with your friends, do all the stuff. Maybe you learned something today. But that's all I got. Thanks for joining me. I'm down to do more of these videos, kind of downloading all the mess that's in my brain after brewing beer in this industry for 10 years. So, na zdraví, cheers. We'll see you soon.